Hello everyone, let's continue this part of Spring Security and let's dive in stateless authentication with JWT. JWT stands for JSON Web Token. It's an open standard for securely transmitting information between parties as a JSON object. This information can be verified and trusted because it's digitally signed, and it can validate its own authenticity without the server having to store any session-related data, which drastically reduces the overhead and potential bottlenecks in high-traffic scenarios. A JWT consists of three parts. Header, which typically consists of two parts, the type of token, and the algorithm being used for the signature, for example, the HS256. This is usually represented in the structured JSON format. Payload is the core of the JWT, containing the actual data we want to communicate. This data could range from user IDs to user roles and additional details. The signature is the JWT's guardian, formed using a combination of the encoded header, encoded payload, and a secret. This is then created by the algorithm specified in the header, and this will be represented as three parts separated by dots. This signature ensures that the JWT remains uncompromised during its journey. It acts as a seal, vouching for the integrity of the enclosed data. The process starts when a user attempts to access a secured resource. The user provides their credentials, typically a username and password. The server receives the credentials and validates them against its database or another trusted authority. If the credentials are correct, the server creates a JWT for the user. This token encapsulates certain user information in its payload, like user ID, roles, or other claims. This token is then signed using a secret key, ensuring that it can be trusted and hasn't been tampered with. Once the JWT is generated and signed, the server sends it back to the client. This JWT serves as a proof of authentication and authorization for the user. When the client receives the JWT, it stores the token, often in a place like the local storage. This storage ensures that the client doesn't need to re-authenticate for every request it makes. Now, every time the client wants to access a secured resource or make any request that requires authentication, it attaches the stored JWT in the request header. This token acts as a proof of the user's identity and permissions. On receiving a request with the JWT, the server doesn't need to recheck the user's credentials in its primary database. Instead, it simply verifies the JWT's signature using its secret key. If the signature matches, it means the token is legitimate and hasn't been tampered with. After verifying the JWT, the server processes the client's request. Depending on the user information encoded within the JWT and the user's permissions, the server sends back the appropriate response or data. Okay, now let's see an example of implementing JWT authentication in Spring application. Here we will also use the same bookstore project that we have created in previous videos. First of all, we need to add the required dependencies. So here I added the following dependencies for handling JWT. JWT API. This is the main API library of the Java JWT framework. It provides the core classes and interfaces required for creating, parsing, and validating JWT tokens in Java applications. This library allows us to generate JWTs, sign them with a secret key, and verify them later to authenticate users or secure communications between services. And this is the implementation library for JWT. While JWT API provides the interfaces and abstract classes, this contains the actual implementations of those interfaces, enabling the API to function. This dependency integrates JWT with the Jackson library for JSON processing. Jackson is a popular library for processing JSON data in Java. It allows the JWT library to seamlessly serialize and deserialize JWT payloads, which are JSON, using Jackson. And of course, we need JAX-B API, which is the Java API for XML binding. It provides a standard way to convert between Java objects and XML documents. And last one is the implementation for JAX-B. So the JAX-B runtime provides the actual code needed to convert Java objects to XML and vice versa. Now let's create a JWT token util class that provides methods for generating, parsing, and validating JSON Web Tokens. It will also help us integrate the JWT with Spring Security by converting it into an authentication object that can be used to manage the user's authentication state within the application. We mark the class as a Spring component, making it a managed bean that can be injected into other classes. This is the key used to sign the JWTs, ensuring their integrity, and is generated using the keys.secretKey4 method, which creates a secure key suitable for the HMAC SHA 256 algorithm. This algorithm is a commonly used cryptographic hash function in JWTs. And this defines the validity period of the JWT. Here it's set to 1 hour. Now let's create a method to generate a JWT for a given user. As a payload, we create a claims object, and the user's username is set as the subject. The user's roles are added to the claims using put roles userdetails.getAuthorities. For date handling, we capture the current time, and the expiration time is calculated by adding the token validity period to current date. The JWTS builder method sets the claims, the issue date, the expiration date, and signs the JWT using the secret key. And the compact method finalizes the token and returns it as a string. And we need a method that extracts the claims from a given JWT. So we have the following steps. Parser initialization. A JWT parser builder is initialized with the secret key using setSigningKey. And the token is parsed with the parse claims JWS, and the claims, which are the body of the JWT, are returned using getBody. After that, we create this method, which retrieves the username from the JWT. It calls the getClaims method to get the claims from the token, and then retrieves the subject, which is the username, from those claims using getSubject. And this method checks whether a given JWT has expired. It gets the expiration date from the token's claims using getExpiration and compares it with the current date. If the expiration date is before the current date, the token is considered expired and the method returns true. Otherwise, it returns false. And the last method is getAuthentication that creates an authentication object based on the JWT and user details, typically used to set the security context in Spring Security. It creates a username password authentication token, which is a Spring Security token that represents an authenticated user. The token is constructed using the user details, an empty password, and the user's authorities roles, and the constructed authentication object is returned. Okay, now we create the class JWT_request_filter. This class intercepts incoming HTTP requests, extracts the JWT from the authorization header, validates it, and sets the authentication context for the current request. This class extends once per request filter, which is a Spring Security filter that ensures the filter is only executed once per request. We need to inject the JWT token util and user details service beans into this filter. The user details service loads user-specific data. It typically interacts with a database or another user store to retrieve user details by username. Here I will create this method. This contains the core logic of the filter. It's invoked for every incoming HTTP request and is responsible for processing the JWT, validating it, and setting the authentication context. The JWT is typically passed in the authorization header of the HTTP request in the format bearer token. The filter checks if the authorization header is present and starts with the bearer prefix. If so, it extracts the JWT by removing the bearer prefix. The filter uses the JWT token util to extract the username from the JWT. If the token is malformed or invalid, an exception might be thrown, which is caught silently, thought it could be logged for debugging. The filter checks whether the username was successfully extracted and whether there is no existing authentication in the security context holder. This ensures that the authentication is only processed if the user is not already authenticated. Here, the filter checks if the token has expired. If the token has expired, no further action is taken. If the token is valid, the filter loads the user details using the method loadUserByUsername. The filter attempts to validate the token by comparing the username extracted from the token with the one obtained from the user details. If the token is valid, the filter creates an authentication object using the method getAuthentication. And sets it in the security context holder. This essentially marks the user as authenticated for the current request. Finally, the filter chain is continued with chain-to-filter, allowing the request to proceed to the next filter or the controller. And of course, we need the class WebSecurityConfig that sets up user management, HTTP request handling, and the application of security filters. Since this will provide Spring configuration, we annotate it with configuration annotation. In this, we'll define beans that Spring will manage. This annotation enables Spring Security's web security support and provides the configuration for the security framework. Now we define the user details service bean, which we already injected in the JWT request filter class. This bean defines a user details service that Spring Security used to load user-specific data. Here, an in-memory user store is set up using in-memory user details manager. It creates a user with the username user, password, and role user. The NOOP prefix indicates that the password is stored in plain text without encoding. We need Authentication Manager bean, which is a core interface in Spring Security for handling authentication requests. It's typically used by the authentication provider to process authentication requests. After that, we jump to Security Filter Chain bean. It includes HTTP security configuration. This method configures security for the HTTP requests in our application. We have the CSRF disable. This disables CSRF, which is cross-site request forgery protection, which is generally recommended in stateless applications. Authorize requests configures the authorization of incoming requests. Request matchers permits all requests to the authenticate and log in endpoints without requiring authentication. And we have the any request authenticated that requires authentication for any other request. We have here exception handling that configures exception handling for unauthorized requests. So we have the authentication entry point that sets the JWT authentication entry point to handle authentication failures, like invalid or missing JWT. And we will create this class in the next steps. And we configure session management using session creation policy stateless that specifies that the application shouldn't create sessions. Instead, it will rely on JWT for maintaining user state, making it a stateless application. HTTP add filter before adds the JWT request filter before the username password authentication filter in the filter chain, ensuring that JWTs are processed before any username and password-based authentication logic. And the HTTP security configuration is built and returned as a security filter chain. The JWT authentication entry point bean that we will create later will handle authentication errors. If a user tries to access a secured REST endpoint without a valid token, this component will be triggered. And we have the JWT request filter bean that we already created, which is responsible for validating the JWTs in incoming requests. Now we can define our JWT authentication entry point class for responding to unauthorized access. The class implements the authentication entry point interface, which is a part of the Spring Security Framework. The component annotation tells Spring to treat this class as a Spring managed bean, meaning that Spring will automatically detect and register this class in the application context. As a result, it becomes available for dependency injection wherever needed, such as in the Web Security Config class. We need to override the comments method from the authentication entry point interface. This method is triggered whenever an unauthorized user tries to access a resource that requires authentication. HTTP servlet request represents the HTTP request made by the client, and the HTTP servlet response represents the HTTP response that will be sent back to the client. The authentication exception is the exception thrown when the authentication fails. Inside the comments method, the code sends an HTTP 401 error response back to the client. So this class ensures that any unauthorized request receives an inappropriate 401 unauthorized response, guiding the client to perform the necessary authentication. Now we need a JWT request to represent the request data that contains the username and password required for authentication. This class implements the serializable interface, which allows instances of this class to be serialized. Serialization is the process of converting an object into a byte stream, which can then be reverted back into a copy of the object. The serial version UID is a unique identifier for the class, ensuring that a serialized object can be correctly deserialized, even if the class structure changes. And we need a username and password that represent the credentials that a user will provide to authenticate. The default constructor is necessary in Spring to create an instance of this class, especially during the process of JSON parsing, when converting JSON data into an instance of this class. And we need the parameterized constructor that allows the creation of a JWT request object with specific values for username and password. And of course, the getters and setters. We also need JWT response class that encapsulates the JWT token that is generated upon successful authentication and returned to the client. Similar to JWT request, this class also implements the serializable interface. Serialization allows the JWT response object to be converted into a byte stream, which can be easily transmitted over a network or saved into a database. The class has a single private field, JWT token. This field is marked as final, meaning it can only be assigned once, either at the time of declaration or within the constructor. The JWT token field represents the JWT string that is issued to the client after successful authentication. This constructor is used to create a JWT response object with a specific JWT token. And lastly, a getter method to access the value of the JWT token. And the last thing we need is the authentication controller class, which is a REST controller that handles the authentication process. So we mark the class with REST controller annotation. The cross-origin annotation allows cross-origin resource sharing, enabling clients from different domains to access this endpoint. This is essential for enabling front-end applications hosted on different domains or ports to interact with this backend service. Now we inject the beans that we need, such as the Authentication Manager, JWT Token Util, and User Details Service. We define a post endpoint at Authenticate. This endpoint handles the login requests. The method expects a request body containing the user's credentials in the form of a JWT request object. Now we create an authenticate method for performing the actual authentication using the Authentication Manager. And in the create authentication token, we call the authenticate method to validate the provided username and password. And we need to load the user details based on the username. And we generate a JWT token for the authenticated user. The generated token is then wrapped in a JWT response object and returned to the client in the HTTP response. Okay, now we can test this by running our application. We send a POST request to the Authenticate endpoint that we created, and we pass the username and password in the body. And here we get the token. Now we can use this token to retrieve all books by sending a GET request to the books endpoint. And here we put the bearer token in the authorization header of the request. And here you go. We could retrieve the list of the books after authenticating. Okay, that's it. I hope you liked this video and thanks for watching.